Good morning. This is Tim Stewart. I am president at Visual Decisions, and we're here today to talk about maximizing equipment availability with Industry 4.0. So, why use Industry 4.0 solutions to maximize availability, and which solutions should we be looking at? So, first off, if we look at this graphic from the World Economic Forum, you can see that there are a number of different solution areas within Industry 4.0. And on the left side, I've highlighted several of them. And in particular, today we'll be looking at advanced analytics with machine learning and AI, I-IoT, or the industrial Internet of Things, and augmented reality for how we can utilize those solutions to improve things. But with Industry 4.0, the technology alone is not enough. And the analogy that I use all the time is a Fitbit. I've been wearing a Fitbit for years, and it's a great IoT device. But it alone is not enough to cause me to lose weight. I actually have to change my behaviors. And so it's the same thing with Industry 4.0. You can put the technology in place, but if people do the same thing tomorrow that they do today, you're not going to see the value from that investment. And so what we preach at Visual Decisions is that you need to combine the smart factory with the lean factory to drive those improvements to cost, quality, throughput, et cetera. And so the next natural question is, how do you go about combining those? Well, over the past forever, manufacturing has really embraced technology. It's been one of the drivers, obviously, behind the Industrial Revolution, and a lot of the progress we've made over the past few hundred years. But continuous improvement is still largely done in a very manual fashion with whiteboards and taped up printouts from Excel and so forth. And if we look at how we can change that, and if you're interested in this topic of how to really drive that combination, I have a number of other webinars on my website at visualdecisions.com where I go through that in more detail. For today, I'll just talk about the fact that to transform operational excellence, you can look at the management system where you look at visual controls, standard work, daily accountability, et cetera, or the lean toolkit with root cause analysis, value stream mapping, FMEAs, and much more. Part of that much more is total productive maintenance. And within total productive maintenance, you have various pillars. At the base, you have 5S, and then you have autonomous maintenance, focused improvement, planned maintenance, et cetera. And within each one of those, certainly Industry 4.0 has a way to help each and every single one of them. But what we're really going to focus on today is maintenance as a whole and being able to increase the availability of the equipment. So if I break down the issues with availability, and in particular, maintenance related availability, you can break that down into how long the machine runs between stops, the amount of time of each stop, and whether you actually fix it correctly on the first try, or the repairman has to go there multiple times. And so I'll handle each one of those in turn. When we look at autonomous maintenance, it's one of the pillars of TPM, as we saw a couple slides ago. And the idea there is to have the operator take as much ownership of maintaining the machine as possible. It's kind of like doing your own basic maintenance on your car. It'll be more efficient, and it'll probably be done with more care since you own the car. But a lot of people don't know how to change their own oil or even wiper fluid. Other than being too busy, the biggest hurdles are some combination of not knowing how, not having the equipment, not having the consumable, whether it's oil or fluids or whatever. And it's the same thing for operators and their machines. They're measured on production. so they don't really have the time. The equipment and the consumables aren't necessarily at the machine. They don't have the instructions of what should be done and when it should be done. They're unsure of when to perform the tasks. There's no obvious prompt for them to do so. And with Industry 4.0, pretty much all of those issues can be addressed. The system will know how many pieces have been made since the last previous activities, so the operator doesn't have to track that. The system can provide a list at any time of what activities have to be performed and step-by-step instructions on how to do it. So, now if I just had those tools set up in my garage, I could do the maintenance on my car a lot more effectively. Preventive maintenance has been a staple of increasing machine reliability in OEE for decades. For such a well-established process, what can Industry 4.0 possibly do to improve it? And it's a lot, actually. So many PM tasks are reactive in nature. They get added when a machine fails in a particular way. The task frequency is often an educated guess without a lot of validation done to optimize the timing. The efficacy of that task is usually not studied to ensure it's preventing whatever it's supposed to, or whether it's needed in the first place. So using a system like I-IoT to collect the data can help address all of those issues listed above. But it has to be done with forethought and intention. We utilize a process to list out each PM activity and identify the following data elements from the machine for each task. First of all, the frequency of the failure mode the PM task is supposed to be preventing. And tracking that data can help tell us whether the PM task is being effective at preventing that failure. We can also experiment with the PM interval to see if there's an impact on the failure mode frequency. And the desire is to do PMs as often as necessary, but no more than that. And then utilizing sensor data and process variables, you have the ability to collect, contextualize, and analyze a lot of detailed data streams. And analysis can be performed to find out which of those data streams are leading indicators for different failure modes. And those are often elements such as temperature, vibration, power draw, et cetera. And the PM can be tied to changes in those indicators instead of using set intervals to further optimize when those tasks should be performed. And use data in that way can help keep the machines running while minimizing the PM costs and the downtime. Condition-based maintenance, this is where the power of the IoT system starts to get really obvious. Everything that we talked about with preventive maintenance still applies, but now we're monitoring the tags and the process variables and setting tolerances on when we need to take action based on the temperature, the vibration, the power draw, et cetera. And so this is where the real power of the IoT system comes in, is the ability to monitor those things, look at that condition based analysis. You can put that through SPC charting. You can just set tolerances on those, and you can immediately alert people once the performance goes outside of those bounds. And you can also prompt some action to take place. And so having that condition-based maintenance in place can take the PMs to a much more sophisticated level. And then there's one more level to go beyond that with predictive maintenance. And essentially, predictive maintenance is taking those same feeds that you're getting with condition-based, but instead of setting tolerances around those individual variables, what you're trying to do with the predictive maintenance is to combine multiple different signals into not just, hey, this machine is getting out of control right now, but based on the way that this is trending and the combination of these different variables, we predict that the machine will stray from tolerance in the future. And so it's essentially the same thing as condition-based monitoring, but a much more sophisticated algorithm to predict the future instead of just looking at the present. Another very widely used tool to address downtime is to look at a Kaizen process. And here we're not looking at a machine that's down right now. What we're looking at is, if we look at things over time, what are the biggest problems that we have? What are the biggest levers that we can pull to improve the operation? And from that, what we're trying to do is run an improvement event to eliminate that cause. And there's a lot of different ways to run Kaizens. This is a very typical 6-step process where first you identify the problems, you analyze the current processes, you create solutions, you test solutions, you measure and analyze those results, and you standardize the solution. Well, at every single one of those different stages, having additional data that comes from an Industry 4.0 solution can very much help you with that step. So if you're just at the beginning and you're trying to analyze what are the biggest problems in my business, having that detailed information of not only how many stops do we have, and at a granular level where you're not filtering out the hidden factory by only having people manually record things that take the machine down for 15 minutes or more. If you're looking at the true complete picture of capacity and what are the problems there, then you can properly identify and prioritize what are the problems that we need to solve. And then going into step 2, looking at the root cause analysis of what are the different factors that are involved here. And whether you do that in a simple way as who, what, when, where, how, why, how, 5 whys, all the way through doing analysis of variance, design of experiments, etc. Having that additional data is going to help you. Another tool in the toolbox, I won't get too deeply into this because I can spend a lot of time talking about how to blend Industry 4.0 and FMEAs. This is another tool that lean people utilize to improve the process. And when you blend it with information coming from the system through smart manufacturing, you can make it tremendously more impactful. So the next step, once we minimize how often the machine goes down, is to get it back up and running much faster once it does. And so with that, we're trying to minimize the mean time to repair. So if we break down reactive maintenance into multiple steps, once the failure occurs, then we have to make sure that the operator is aware of the problem. And then the operator has to do some level of diagnosis on this to see if this is something that's, there's just a jam that they can clear, or if this is something where they need help. And if this is something where they need help, they have to, raise a ticket with maintenance. They have to call engineering, whatever it might be, and, get other people involved. Then, maintenance is going to assign, a person to this. That person has to become available if they're working on something else. Then they have to travel to the machine. And now, for this whole process, we've finally gotten to the point where maintenance actually gets to the machine. And from there, we can look at, how long it takes them to diagnose the issue, fixing the issue, and yay, our machine is back up and running, it's fixed. Or, we have to try again later because even though the maintenance person may have been able to diagnose the issue, they weren't able to fix it. Maybe they didn't have the right tooling, the right parts, something along those lines. Or it could be that they weren't able to diagnose what the problem was in the first place. And so we'll get to the first time fix rate later, but just looking at those first steps in the problem. Laying this all out on a timeline, if we look at how the machine monitoring and visual factory can impact this, once the problem stops, the operator may not be standing right there by the machine. If you've got a long line, it may be that they're at a different part of the line. If An operator is handling multiple machines. They might be away from the machine that goes down. And so the first step is to simply have that signal some form of visual factory to let the operator know that there's a problem. And so we can shorten the time that step takes. The second step is that we can actually apply analytics here. So if we are pulling information from the controller, we can look at fault codes. We can look at additional sensor information such as temperatures or vibration or noise or anything like that. And we can utilize that information through machine learning algorithms to automatically classify what the problem is. And when we do that, we can not only notify the operator that there's a problem, but we can let them know, in many cases, what the problem actually is. And so by doing that, we can reduce the amount of time it takes not only to make the operator aware, but also look at the operator knowing that they're going to need assistance. And once somebody arrives at that machine, how long it takes them to diagnose the issue to actually get it fixed. And then the next step beyond that is adding integration. So if we're not only looking at the machine itself, but we're tied into the maintenance management system, we're tied into engineering and so forth. As soon as we understand that there is a problem, we've classified what type of problem it is, we can actually automatically create a ticket within the maintenance system. Knowing what type of problem it is, we can work with that system automatically to assign the right type of person, whether it's an electrical failure or a mechanical problem, something like that. And we can even pull in engineering if we need to. And so by knowing what type of problem it is, we can automate a lot of this process and significantly shorten these cycles. And then kind of in an ideal scenario, we're not only able to notify those people, but we can actually provide remote assistance to the operator so that nobody has to travel to the machine. The maintenance team or the engineering team can actually instruct the operator what to do, just using their smartphone as a communication device. And so, when this type of thing is possible, we can actually shorten every single part of the cycle, except for, actually fixing the problem, which can be done, again, by the operator themselves with that remote assistance. So, in certain cases, we can dramatically decrease that time to repair. All right. So then in terms of maximizing the first time fix rate, why doesn't something get fixed on the first try? And there are many possible reasons. So I talked a little bit about electrical problems versus mechanical. And, a lot of times maintenance is just kind of guessing what the problem is and sending, a repairman out there that may be qualified on one type of, issue, but not a different type. And if they guess wrong, well, then they've got to, correctly diagnose it, get the other person out there, and you have to wait that much longer. So, if we're able to do that classification in the first place and, notify maintenance of what the general problem is, then certainly we're going to be able to do a better job getting the right person assigned in the first place. It may be that, the maintenance person, when they go out there, have a difficult time if they don't have this data available on what was happening, right before the machine went down. They might not be able to see, what the problem was. Once they get there, half an hour later or whatever, there may not be, a whole lot that tells them what was going on beforehand, especially if the operator, wasn't there watching the process. So in a lot of cases, they don't have the information that they need to diagnose, what the actual root cause of the problem was. But if we have all of that detailed information and have that classifier system in place, we can certainly short circuit that, where the classifier system can recognize the issue. But having that additional data can also help the maintenance person understand what was going on with the machine prior to the downtime and help them much more accurately diagnose, what the issue is on their first try. The next step is having the required parts in stock. And, at first it may not seem like this is something that, an Industry 4.0 system can help with, but if you look at the entire history on this machine and you're able to, compare, this past spares consumption, you have some forecasting capabilities on, what those spares should look like, the spares inventory should look like. But if you also have machine learning in place to predict what are the upcoming failure modes, that gives you time in order to get those materials in stock prior to the machine failing. And that gives you the ability to actually have those parts on hand, when that failure does occur. And so, having that additional data, having those additional analysis capabilities can certainly help you stock the right parts at the right time. Very often the maintenance person will go out to the machine, do the diagnosis, and then they'll have to go to the spares area or the tooling area in order to get the right materials to bring back to the machine in order to fix it. Just having something in place as simple as a better communication system and better communication framework that you can get with an IoT system is going to be something that allows you to have the maintenance person request those spares to be brought to him at the machine by another party within the plant. And that way they don't have to leave the machine. They can be doing their work, request those spares, continue with their process, have the spares show up, and then utilize them to fix the equipment, which can significantly reduce the amount of time that they have to spend there. Same exact thing for the right tools. Instead of having to go to the tool crib, they can just have those parts brought to them or those tools brought to them and then utilize them at the machine as they're needed. Fairly often the maintenance person will get out there and they'll need additional assistance. They're either not fully able to diagnose the problem or they're not able to fix the problem on their own. They may not have the right procedures. And so they need help. And, in a lot of cases, they have to go, walk to the engineering office, place phone calls, do other things, wait for people to show up. With tools like remote assistance through augmented reality, they're able to engage people from engineering or even the vendor of the equipment itself, and get that assistance to be able to make that fix at the machine while they're there the first time. And very similarly, they may not know how to make the repair. And if they can, first of all, get that upfront diagnosis, if that can link to a digital work instruction system, if this is something that, this repair has been made in the past, you can actually start collecting a library of, if you have like augmented reality glasses, the first time that you're making a new repair, you can capture that with the glasses. And then it becomes part of the library so that if that type of downtime ever happens again, whatever repairman goes out there, or potentially even the operator, they would be able to look at that video of how that diagnosis was reached or arrived at, and they can walk through the steps of how to actually make that repair and be able to do that in a much more efficient fashion. So these aren't the only reasons that machines go down. Machine breakdowns are just one example of why you have availability issues on the machine in the first place. check back with us in future weeks. We'll do deep dives into these topics as well, looking at setups and changeovers and how you can optimize those, looking at process failures, whether it's having a machine that is either starved of materials or blocked downstream, or any other type of process failure, manpower issues, material issues, and so forth. So with that, I thank you very much. And if you want to, you can reach out to me at tim@visualdecisions.com. My phone number is right there. I look forward to hearing from you at any time. Thank you very much. Bye-bye.